Welcome to 15 Minutes Health, your source for clear, evidence-based insights in nutrition, neuroscience, longevity, and everyday wellness. Each video delivers science you can trust, designed to help you build a stronger, healthier life, all in under 15 minutes. Subscribe to the channel so you never miss practical, science-backed tools that can improve your health for the rest of your life.
Today, we're diving into one of the biggest questions in all of biology. Why do we have to get old? For basically all of human history, aging was just seen as this inevitable decline, something that just happens. But the way we think about it is completely changing. We're in the middle of a huge shift, where science is showing us that aging might not be a one-way street after all. And the key here is to understand the difference between lifespan, that's how long you live, and health span, which is how many of those years you're actually healthy and feeling good. The goal isn't just to add more years to your life, but to add more life to your years. So in this explainer, we're going to unpack something called the information theory of aging, which says getting old is really about our cells losing information. We'll look at the body's ancient survival circuits, these built-in defense systems, and the fuel they run on. And most importantly, we're going to turn all this science into practical, real-world tools, things like fasting and supplements that you can actually use to take back some control over your own biology. And to see what's possible, we don't even have to look into a crystal ball. We just have to look at people who are alive right now. You've probably heard of super-agers. These are folks in their 80s and 90s who have the memory and sharpness of people decades younger. We see the same kind of thing in places called blue zones, these pockets around the world where people just live incredibly long, healthy lives. And these people are so important because they're basically our proof of concept. They show us that having a long, vibrant health span isn't just about winning the genetic lottery. It's an achievable goal. And it turns out their lifestyles are, often without them even knowing it, flipping on the exact same longevity switches that scientists are just now figuring out. So what's the secret sauce here? What do these groups have in common? Well, when you look at the research, a few things pop out again and again. Super-agers tend to have more gray matter in their brains, and they stay incredibly mobile. Both groups are usually really active, they eat diets that are full of plants, and they have these really strong social circles. But here's the thing, and this is critical. These are all correlations. They tell us what these people do, but it doesn't explain the biology. It doesn't tell us why it works. To really learn from them, we've got to go a level deeper and ask what's happening inside their cells. And that brings us to the big question, right? Is this all just random genetic luck? Or are there actual biological levers we can pull to get the same results? Well, the science is becoming crystal clear that the answer is a huge yes to the second one. The key is to stop just looking at what these people do and start understanding why it works on a molecular level, because that understanding, that's what gives us the power to actually do something about it. All right, so here's our game plan for today. First, we're going to tackle the big idea. What even is aging at its core? Then we'll dive into the body's amazing built-in survival circuits that are designed to fight it. After that, we'll switch from theory to practice, and we'll look at specific tools like fasting and supplements and exactly how they work. We'll also break down this really important trade-off our bodies have to make between growing and repairing. And then at the end, we'll pull it all together into a protocol that you can actually start thinking about. Okay, so to figure out how to slow aging, we first need to know what we're up against. And one of the biggest ideas changing the game right now comes from Dr. David Sinclair at Harvard. It's called the information theory of aging. And the big idea here is that aging isn't our body's hardware failing, it's the software getting buggy and corrupted over time. To really get this, we need to talk about something called the epigenome. So think of your DNA as the hardware. It's the blueprint with all of your genes. The epigenome is the software. It's this layer of chemical tags and proteins that sits on top of the DNA, and it tells each cell which parts of that blueprint to read. It's the reason a heart cell acts like a heart cell and a brain cell acts like a brain cell, even though they have the exact same DNA inside. An easy way to think about this is with a metaphor. Let's say your DNA, your genetic code, is a brand new compact disc. It's perfect. It has all the songs, all the information needed to make and run you. And that CD is incredibly durable. The information itself is solid. Now the epigenome, that's the CD player. Its job is to read the disc and play the right song at the right time. For a skin cell, it plays the skin cell track list. For a neuron, it pulls up the neuron playlist. This super precise, organized reading is what keeps everything running smoothly. Okay, so here's the absolute key to the whole theory. Aging isn't the CD itself breaking down. It's scratches getting on the surface of the CD. Things like UV rays from the sun, toxins, just the daily grind. They cause tiny breaks in our DNA. These are the scratches. And every time there's a scratch, the CD player, our epigenome, has to stop what it's doing, go fix the damage, and then try to find its place again. Over decades, it gets jostled around so much it starts to get lost. It forgets which song it was playing. A skin cell might accidentally start turning on genes for a kidney cell. It's this loss of identity, this epigenetic noise, that is the root cause of what we call aging.
And this is where it gets really exciting and honestly pretty empowering. Because what this theory suggests is that about 80% of our longevity is controlled by the epigenome, that software that's influenced by our lifestyle. Only about 20% is the hardwired DNA we get from our parents. What that means is that those scratches aren't our destiny. We have the ability to influence the system. We can help polish the disc and help the CD player find the right song again. The choices we make every day are literally programming our cellular software.
Okay, so if the problem is our cells losing information, the next big question is, does our body have a built-in antivirus program? And the answer is a definite yes. It's a set of ancient survival circuits, genes that have been around forever in everything from yeast to us. And they're designed to protect us when times get tough. These are our longevity genes. At the center of this survival circuit are 7 proteins called sirtuins. You can think of sirtuins as the body's emergency response team. Their main gig is to keep the epigenome stable. They're the ones who go out and polish those scratches on the CD. But here's the catch. They aren't working all the time. They only get switched on when the body thinks it's under a little bit of stress. It's a concept called hormesis, which is basically the idea that what doesn't kill you makes you stronger, literally, at a cellular level. A little bit of stress is good. Now, this emergency response team can't do its job on an empty stomach. It needs fuel. And the crucial fuel for sirtuins is a molecule called NAD. You can have all the sirtuins in the world, but without enough NAD, they're just sitting on the bench, totally inactive. And here we run into one of the biggest problems with aging. As we get older, our natural levels of NAD just tank. By the time you're 50, you have about half the NAD you had when you were 20. This creates a huge energy crisis in our cells. It means the fuel for our main defense system gets super low, leaving our epigenome way more vulnerable to those scratches. So a huge part of any longevity strategy has to be about finding ways to boost NAD and get those sirtuins back on the job. So that brings us to our first and maybe the most powerful tool in the toolkit, creating a little bit of caloric stress. The easiest way to do this is through fasting, or what's called time-restricted eating. And it all comes down to the signals our cells are getting. See, when we're constantly eating, our cells are swimming in signals of abundance. They're told times are good, focus on growing and dividing. But when we fast, when our insulin is low, the body gets a completely different message. It senses a mild threat, that hormetic stress we talked about. And that signal is exactly what flips the switch and tells the sirtuins to wake up and start their defense and repair work. And the power of when we eat is just incredible. Get this. There was a massive study on mice where they fed them all sorts of different diets. High fat, high carb, you name it. But the one thing that predicted who lived the longest wasn't what they ate. The mice that lived way longer were the ones that were forced to eat all their food in a small window of time each day. That tells us that activating those sirtuin defense pathways every single day through fasting might be an even bigger lever for longevity than the food itself. So, how do you actually do this? Well, a really simple way to start is just to skip one meal a day, like breakfast or dinner. That just naturally extends your overnight fast. From there, you can try to shrink that eating window down to, say, 8 hours, or 6, or even 4. And during the fast, just stick to water, black coffee, or tea. Now, the first couple of weeks might feel a little tough as your body adjusts, but stick with it. Consistency is what teaches your body to get good at switching fuel sources and reliably turns on those protective genes. Okay, so fasting is a powerful behavioral tool. But beyond that, scientists are looking at specific molecules that can give these longevity pathways a direct boost. Basically, ways to give the sirtuins, the activators, and the fuel they need to do their best work. Let's look at a couple of the big ones. So 2 of the molecules that have been studied the most here are resveratrol and NMN. You can think of resveratrol as the gas pedal for your sirtuins. It makes them work harder. And NMN is a precursor to NAD, so it's like putting more gas in the tank. The idea is to directly refill your NAD stores, giving those sirtuins the fuel they desperately need. Dr. Sinclair's personal approach is about 1 gram of each in the morning.
One pro tip is that resveratrol is fat-soluble, so you want to take it with something like yogurt or a bit of olive oil so your body can actually absorb it. And of course, and this is important, you should always talk to your doctor before starting any new supplement routine. Now, turning on our defense pathways is only half the story. Our bodies have another major system that pretty much does the exact opposite. It's a growth pathway. And understanding the balance, the trade-off between these two is absolutely essential. So you've got this fundamental tug of war happening inside your body all the time. On one side, you have the sirtuin survival circuit. We turn that on with things like fasting and exercise. It's all about repair and long-term health. On the other side, you have the mTOR pathway. This is our growth circuit. We turn that on with protein and insulin. It tells our cells to build muscle, grow, and multiply. And I want to be clear, neither one of these is good or bad. We need mTOR. It's essential for building muscle and recovering. But the problem is when mTOR is switched on all the time, leaving no room for the repair crew to come in. The real goal for longevity is to cycle between the two, periods of repair and then periods of growth and rebuilding. All right, we've covered a lot of ground. We've talked about aging as a loss of information, we've met the key players like sirtuins and NAD, and we've looked at some powerful tools to influence them. So now, let's put all the pieces together into a clear set of takeaways. So here are the big levers you can actually pull. First, practice some form of time-restricted eating to give your body that daily dose of healthy stress. Second, eat a lot of plants, especially colorful ones. Those colors are often stress defense molecules that turn on our own defenses when we eat them. Third, exercise. It's another fantastic way to create that healthy stress and boost NAD. Fourth, if you're interested, you can look into targeted supplements to directly support that NAD sirtuin system. And finally, let's not forget what we learned from the Blue Zones. Manage your stress, get good sleep, and build strong social connections. All of those have a huge impact on our biology. And if you're wondering just how much of a difference all this can make, check this out. A huge recent study on U.S. veterans found that adopting just 8 of these healthy lifestyle habits could add up to 24 years to a person's life. 24 years. That's just a powerful reminder that the small choices we make every single day can have a massive impact down the road. So we'll leave you with this idea. Thinking about aging as a loss of information just completely reframes the whole problem. It suggests it's not permanent damage, but a reversible loss of instructions. And that opens up a pretty incredible possibility. If our cells are just losing their way instead of being broken forever, it leads to the ultimate question. Can we go beyond just polishing the scratches on the CD and actually figure out how to do a full system reboot? Can we restore youthful information to old cells? Now that might be the future, but the amazing thing is, the science we've talked about today gives us powerful tools to take action right now. By understanding how all these pieces fit together and using tools like fasting and exercise, we can stop being passive bystanders and start actively shaping our own health span.
Thanks for watching 15 Minutes Health. If this video helped you, consider subscribing. Your support allows us to keep creating clear, science-backed content to help you stay healthier, stronger, and better informed. See you in the next video.